Hello everyone. Thanks for joining the webinar today. Very good evening and good morning for the global audience. My name is Kalyan. I work for S&P Global and my role is heading the team of developers who are responsible for creating the content collection tools and standardization of the data and building analytics on top of that. To give a little bit of background on S&P Global, S&P Global is a financial information and analytics provider for institutional investors. So S&P Global internally has multiple divisions specifically focused on key areas. So some of those four of those divisions are existing within S&P Global. They are market intelligence, which is focused on collecting the market data and fundamentals information required for investing decisions. And we have ratings as a division, which is providing ratings for the corporations and instruments. We have S&P Global Platts, which is used as a benchmark for commodities pricing. Then we have S&P Dow Jones Indices, which is an index of S&P 500, which maintains the index of S&P 500 index. So these are four divisions. They have very unique focus within their business. Now, so today's topic is data intelligence. We are going to cover what is the importance of business intelligence, data intelligence in strategic decision making, and we will see how organizations can adopt data intelligence. And we will also see a little bit of glimpse about how data engineering is changing in the world of data intelligence. So let's go ahead and start this one. So why data intelligence? We have seen in the last decade how business intelligence is really giving value to businesses. So we have heard about it, all the combining all the operational data sources into data marts and then running analytics on top of it and then creating value, right? But however, this the there is a shift in recent days from business intelligence to data intelligence. Where is it coming from? So the value of data is already a sold concept using business intelligence, right? Now the key question is how much value data can provide to organizations. That's the key question that organizations are going through right now, because a lot of new ways of using data are emerging. Data science is becoming the sixth sense for organizations these days. Now, are organizations really having enough potential to drive the full value of the data is the question. On the other hand, if we really see how data is growing, so the study says that every day 2.5 exabytes of data is being created in the world. Now, where is the value of all of that data going? Are organizations really benefiting from a lot of this data explosion that is happening every day? On top of it, we can understand that 90% of the data that is created in the human history is only created in last 2 years. So that can give us the uh, imagination of explosion of data in the recent years. So if 90% of the data is grown in last 2 years, whether organizations really gain 90% of the value is another question, right? This value might be gained by startups or multiple new companies that are coming up who are innovatively using the data, and some of the companies like Google and Facebook might be gaining a lot of value out of this data, right? But this is an opportunity for every organization now to think about how they can gain also value out of this data explosion that is happening. So this data is growing across every industry every day, right? So the potential of that data and value chain of that data is leaning the organizations towards data intelligence. What is data intelligence really? It is a multidisciplinary field combining the data engineering, data science, machine learning, and data visualizations. So it's a multi-stream thing. It's data science. Data intelligence is not a technology per se. It's a concept. Let us look at some examples how data is being innovatively used and value is created. Foot traffic data is being used for predicting the sales of retail industries. This is increasingly becoming a trend in the industry. If we look at some of the examples, uh, a company called Foursquare has predicted the Chipotle sales will go down by 35% in 2016, and it came true. That, and they also predicted iPhone sales will be around 12 to 15 million for iPhone when iPhone 6 was released, and that also was well within the range of their prediction. So that is a great example of how foot traffic data is being used for taking decisions on investing in retail industries. Satellite imagery is completely revolutionizing the investing decisions in commodity markets. Satellites are really monitoring the Earth activity, which means anything that is physically available on the Earth can be monitored, and insights can be gained from that monitoring. Some of the examples are like there is a company called Ursa, which is monitoring the oil rigs on the earth, and it is predicting the volumes of production volumes and also the logistics around the crude oil. So how can that help the organizations who are really investing in oils, for example? That's a hugely valuable information for them. Another example is satellites can easily monitor the agricultural space, right? So they can monitor what type of crops are really growing in various parts of the world, and they can easily predict the demand supply within those locations, and then that can really give insights to people who invest in commodities markets. Industrial sensors are creating revolutionary technologies. One of such example is digital twins. Digital twins is nothing but creating virtual models for the physical uh, infrastructure, physical machinery, in other words, right? So the physical machinery, each component in the physical machineries are embedded with sensors where all of the data of those sensors are being gathered, and then a virtual model which is very similar to the physical model is created, and the virtual model really predicts how the physical model might be working, even though they are not in an unattended mode, right? An example is the GE. GE made this concept for their aircraft engines. So they have made a virtual model for the aircraft engines, which can predict when aircraft engines really need servicing or replacing the parts. That is another valuable use case using the sensors, and that gives a uh, good satisfaction for customers for giving a better service. ESG data is increasingly becoming relevant for investing decisions. What is ESG? ESG is environmental, social, and corporate governance aspects. So Responsible investing is making decisions based on how the environmental factors will play for the companies in valuation of the companies also, right? So typically, companies which are actually deteriorating the environmental value by large amount of carbon emissions or fossil fuels are considered less for investing. The other factors around ESG also could be that the availability of raw materials could be a factor for valuation of the companies. Nowadays, the raw materials can be easily monitored and then know how long companies can really use those materials and then gain value. And there are some other aspects even in ESG around social aspects. So we have seen an increasing trend in the organizations for diversity and inclusion. I think we recently S&P Global has made a campaign around change base. So it actually demonstrated the data around how the economy would have benefited by engaging more women in the employment. So it has a lot of insightful data in that one. So diversity is becoming a social factor for investing in companies. And the other factors also including corporate governance. What is the management structure looking like? And how the compensation structure looking like? All of these things are playing crucial role in investing decisions. And nowadays, companies are being rated on ESG factors. That gives us a hints about how data is being utilized. These are unconventional data sources. These are not the data sources that typically business intelligence was using so far. Social media is becoming a good channel for companies to do the branding and also gaining insights from customers about how their products are being uh, reviewed and rated in social media. So there are social media analytics products these days that are being sold to organizations, which is giving insights for organizations to build better products for their customers. Surveys, digital surveys are everywhere these days, right? We go on a Uber ride, you will get a survey. That's just one small example, but surveys are being used within the companies to really gain insights from ranging from employee engagements to also taking industry surveys to really predict the trends around the industry. Now, customer interactions are increasingly being digitized by organizations to really know the customer behaviors and then build products which are persona based. Personalized products are being increasingly giving competitive advantage for companies. So digitization of customer relations is changing the way people use the data. Finally, I want to talk about this example of tulip flowers. So in Netherlands, large amount of crop is about growing tulip flowers, right? So recently, Google is partnered with a academic institute, and then they have researched and then digitized the roots of these flowers, and then they decoded the language that these flowers are using to communicate with each other through their roots. So what they have done is that they have digitized all the roots information available in these roots, and then they build the machine learning models to really translate these flowers language into human readable language. So this is a great example of how data is being created and innovatively used, and then now Google is helping the farmers in Netherlands to really grow these tulip flowers, and it's a huge benefit for them. So these are all unconventional data sources and then innovative use of data to really gain some value, right? So what are the actual drivers in the industry that are causing a momentum of data intelligence? So if we classify, it becomes these four factors. One is the digital transformation. Organizations are increasingly digitizing the information. IoT is emerging as a core of the manufacturing industry, and every organization is trying to go paperless. So all of this digitization of information is either an advantage for the organizations themselves, and sometimes that information can be helpful for other organizations. So there could be increased monetization of the data with digital transformation. The other one is innovations with using data that we have seen examples how data is being innovatively used. And the other one is cheaper storage and computing. So building data centers these days is a old concept. Nobody is trying to build data centers. If organizations have to uh, experiment with an idea, it is now with the emergence of cloud, it is just a matter of days. Previously, it used to take months and years to really build the infrastructure and then try the idea and then see how it is successful or failure. So now that's all gone. It is a matter of days, and then it's not even about servers. I mean, cloud computing these days emerging as serverless computing. You don't need servers, and you pay as you go. There is no upfront cost and investment that you need to pay, right? So that is revolutionizing the industries to really fasten their experimentation. Technology advancements. So we have seen how data is growing enormously, right? So few years ago, there is there are no frameworks to really handle data at that scale. But now, with the emergence of distributed computing, uh, we can process the data at petabyte scale. There are databases that can host petabyte scale and then process petabyte scale data. So this is another area which is driving data intelligence. All of these factors combining together is giving organizations an advantage to really use data innovatively and drive value, right? However, if organizations has to benefit from all of these things, they have to adopt this in a meaningful way, right? So if data intelligence adopted in a rush or in a non-meaningful way, rather than really creating value, it could actually become a debt for the company. So what are some of the aspects that organizations can focus on to build this data intelligence meaningfully? So data intelligence should be built as an ecosystem rather than a project-based thing in the organizations, right? So if it has to be an ecosystem within the organization, it has to be embedded into the organizational strategy. It has to come top down, uh, and data strategy has to be part of the enterprise goals, and there should be a meaningful way to measure the value coming out of the data usage. And it's also relevant to say that it is also organizational culture that drives the innovative use of data within organizations. Apart from the strategy, governance plays a lot of role in making the data intelligence successful. So governance empowers the users in the organizations to use the data and then make decisions with the data. Well, while it actually empowers the users, there are also factors that data governance controls to mitigate the risks for the organization. So governance really plays a crucial role to define the data definitions within the organization, and it also controls the policies how data should be used and standardized, and it deals with also the compliance and risk aspects around data, right? That is a crucial factor for the organizations to focus on. We have seen examples of how costly data breaches are becoming in the industry these days, right? We have seen how Cambridge Analytica case is emerged. So data is being seen as a critical asset, and also there are critical controls being made in the emergence of regulations around data. So data quality is another area of data governance, which gives trust on the data in the organization and also to the customers, right? If customers has to trust the data, it has to be top-notch quality. And data governance puts in processes and measures to make sure the data is of good quality for decision making. So next is processes and tools. So in order for data to be utilized in a meaningful way, and also in order to maximize the benefits and experimentation with the data, there has to be foundational capabilities that should be built around data access, and then how data can be analyzed, and then how data can be packaged, right? Data packaging is another crucial aspect, because that's where every department within the organization can reuse a packaged data set. Otherwise it becomes a siloed approach. So breaking the silos is very, very important for gaining value out of data intelligence. The other focus area is around data assets. So curating and managing the data assets is very important. Data is being treated as asset, and it is an asset at enterprise level. So it is important to focus on managing those data sets. So the data sets could be around market data, or organization's internal data, or it could be alternate data. So we have seen examples of alternate data before. So organizations continuously has to focus on what is the relevant alternate data that could benefit for their decisions within their organization, also for their customers. These are the building blocks at a high level for organizations to focus on to build a meaningful data intelligence. So, what are typical challenges in data intelligence, right? If it is not done meaningfully, there can be these challenges, right? The first one is relevancy. So with explosion of data, and then enormous amount of data sources available in the market and industry, it can be uh, it can be hard to really find relevant data for decision making in the organizations. The next one is about lack of data dictionary. So this is a typical problem even in the previous world. So organizations traditionally has created data within their siloed individual organizations, and there is no consolidated data dictionary that can be used to use the data meaningfully and take decisions, and it always becomes a conversational exercise to really understand the data, and those conversations will take a lot of time, and there is also interpretation aspect of it. So data dictionary becomes a challenge. Integration, again, if we have to integrate multiple data sources within the organization itself will also become a challenge if appropriate data governance and policies are not defined well. Data literacy is going to be a challenge. Uh, Making people understand how data can be used and then how value can be derived from the data is one challenge that organizations go through. Then external risks. So lack of proper governance and compliance insight can lead to external risks for the organizations. It also covers the areas of how the vendors that are giving the data to organizations are vulnerable to either legal problems or how sustainable their businesses are is also a contributing factor. We have seen in the previous examples how raw materials are a factor for valuing companies, right? Now, exactly in the similar way, data could be a raw material for the organizations. So, if the source of these raw materials are vulnerable, it becomes challenge. And then data privacy could be another challenge, right? So organizations can really democratize all of the data and then say, hey, everybody can use data, but it is not really true that everybody has same level of access to the data. So that becomes a challenge, that becomes even prone to issues, legal issues, right? So maintaining a consistent data privacy and defining the policies and rules around who can access the data and what data is a challenge if it is not meaningfully implemented. So, what is role of data engineering in this whole data intelligence world, right? So, if we really think data intelligence as a ecosystem in the organizations, we can see data engineering as a glue that can stick the ecosystem together. So, how data engineering really helps, what it really does, right? So, it does these things. And this is not an exclusive list, by the way. These are core things that actual data engineering does. So it creates data engineering plays a crucial role to create master data repository and metadata services. So we talked about data governance and then data definitions. This is where data engineering comes into picture. They work with the domain experts for the data, and then they create the master data repository for the organization for everybody to use. And metadata services helps the developers to really automate some of the data processing aspects by using the metadata. Now, data engineering also builds the foundational capabilities around storing and accessing the data. Then data engineering also creates data flows to ingest and transform data for uh, for usages in the further pipelines. A good example is that the data science, right? Data science is one of the field in data intelligence. So typically, for data science models to work, data has to be available in a consumable format. So data engineers play that role of really making the data available in the consumable format. So data engineering also creates APIs for packaging data so that everybody in the organization can use the data, and sometimes products can use those APIs and then APIs can be productized. So if we go a little bit uh, deep into data engineering, various aspects of data engineering, here are some of the things that happens underneath, right? When we look at data sourcing, sourcing can happen from multiple channels. So they could come from uh, streams either from IoT devices or maybe streams within the organization. Event-driven data processing is increasingly becoming popular, right? So data could come from streams, data could come from data feeds, data could come from the actual relational data stores available within the organization. Sometimes even the data providers really gives the databases, and they host their applications to manage those databases. So that becomes one source for acquiring data. And the other one is APIs. So people can also expose APIs to sell their data, and then that becomes one source. These are typical standard sources. There are various other sources that we can think of, right? People can do web scraping. People can do uh, some organizations really do TCP listening for their data selling. So they transmit over TCP channel, right? So data engineers must be equipped to really work with different types of data sources in and ingesting from those sources. When it comes to data processing, these are typical things that happen, right? So data comes in raw format. So there may be needs of cleansing the data for to make it usable. Sometimes we need to transform the data because typically data models vary between organizations to organizations. Unfortunately, there is not much of a standardization of data models. It's probably also not feasible, right? I mean, a good example probably some of the new initiatives are emerging in this area to really reduce the burden of transformations. Microsoft recently started an initiative, open data initiative, in partnership with Adobe and SAP. And what they're trying to do is that they are trying to create a single model for their customer data. And reportedly, they also have plans to increase that concept to uh, other industries and models. So if we have one model and everybody is using that model, think about how easy it would be to really exchange data, right? So hopefully that initiative succeeds and stuff, but it's very new, right? And it cannot probably scale to every use case in the world. So transformations needs to happen. The other area of data processing is aggregations. So aggregations is about deriving more meaningful value out of the raw data. So sometimes vendors may not be giving all of the data that we need to take decisions. So this is one processing aspect. Now persistence. So persistence, although it looks very obvious, in data processing, persistence needs to be thought through a little bit. I mean, again, it depends on volume of the data and also the type of data stores that we are dealing with, right? So if we have a high volume data streaming process, and if our data store, for whatever reasons, is not scalable to really accept that level of writes, we may need to buffer the data, right? So we may need to cache and buffer the data for persistence. So that is another aspects within the processing that needs a little bit of thinking. Then the other part is building data analytics, right? So this covers the internal reporting around the data and building dashboards for decision making, building APIs like we talked about, and predictive analytics. This is important one. I mean, and again, relevant for data intelligence, right? So data engineers themselves may not be data scientists. So data scientists works mostly on the creating the models and then driving predictive analytics and value out of those models. So at some point of time, those models has to be productionized, and those models has to be embedded into the data flows. So data engineers take on those models and then they productionize it. build those models into the data flow such that the value chain is established for the organization. So they work very closely with data science teams. So the other aspect of data engineering is enabling operations around data, right? So although I mentioned it as a separate item here, actually in the practical engineering, it has to be embedded within the process. So it can't be a separate one. But however, for the purpose of discussion and give what happens within the that thinking, so the API's health needs to be monitored, right? So there has to be a consistent logging that should be happening while data engineers are building the APIs. So data store performance needs to be monitored, and uh, there must be alerting functionality whenever things go wrong, right? And there should also be enough thought put into place that hey, how systems can really self-heal themselves without attending by somebody, right? Sometimes it is possible, sometimes it may not be possible. People will just rely on alerts, right? So these are some of the areas data engineering focus on within the organizations. Then how we can see now how technology landscape is changing for data engineers with in the relevance of data intelligence, right? If we really see, I tried to classify these into three areas, right? So with explosion of data, a lot of data processing is moving towards streaming, and we do have use cases around batch processing, and analytics are typically run in batch modes, but more and more data in the recent days is coming up as streams, and IoT is all streams, right? So so data engineers should be well versed with streaming technologies. What are some of the streaming technologies, right? Kafka is predominant streaming engine. Then we can see Apache Flink, and in the cloud we have Amazon Kinesis and Azure Streams and Google Dataflow. These are all stream-based technologies within the cloud. So if we really think about streams, we need to understand what are some of the things that a streaming pipeline should really have, right? So it should be fault tolerant, first of all, right? What happens if a failure occurs for the infrastructure when streaming is happening? And what happens if we need to replay the messages? And how can we really manage the state in the streaming pipelines? How can we scale the streaming pipelines? Because streaming is typically understood as a queuing of messages, right? So some of these things are crucial factors to really selecting a right streaming platform. So Kafka is having rich set of features to really uh, build a sophisticated data pipelines, streaming data pipelines. It also has good features of uh, windowing aggregates of the streaming data, and it also has features to really query the streams with with KSQL. So there is a integration to Kafka with KSQL, right? So that's basically how we can query Kafka streams just like SQL. So that's a pretty good feature to have. And the other aspect here is data stores. Purposefully, I did not put the traditional relational databases here because we have known them from decades, right? So, for the purpose of discussion, I limited these things to some of the distributed databases. Now, if we really look at from a data store standpoint, and from some of the technologies that are mentioned here, one thing to note is that there are multiple models emerging to store the data, right? What do we mean by model here? It's not like a traditional data model that we are talking about. These are storage models. So if we really think about it from the technology's perspective here, MongoDB is a document store. The storage is optimized and the technology is optimized for storing document-oriented data. And Hive is optimized for relational data. And Neo4j is optimized for storing graph data, right? And DynamoDB React is key value stores, right? Now, data engineers really need to understand when they want to really choose a right data store for their data, they need to understand what are the options available for storing their data, right? That involves a little bit of research and deep understanding of the data and also the use cases of how the data should be used, right? So, for example, if we choose Cassandra, for example, right? So it's a um, Cassandra is a very use case based database. So it's a very high throughput read rate intensive database, and it can scale very well, and it's a multi-master replication, right? So your writes and reads both are uh, spread across the cluster. Now, but however, you need to be really, really thoughtful of how data should be used to provide value when we are choosing Cassandra as a data store. Because once you build your model in Cassandra, if you later realize that you have a different use case, then the model doesn't work. You need to copy the data in a different model. So that's a little bit shift from how we can actually query the relational databases. If you have a relational model, you can write SQL queries in different ways to really do that, right? So it is optimized for such type of a use case based modeling, and then obviously it gives pretty high throughput. There's no doubt about it, right? So similarly, MongoDB, right? So when we choose these data stores, some of the aspects that we can think about are that, hey, what is the model of the database? And what is the replication model? Is it a master-master, multi-master replication, or is it a master-slave replication? What is the consistency model? And and what is the availability and scalability of the data store, right? Now, there is a concept of cap theorem that probably every data engineer will be well versed with, right? So in a partition scenario, right, if the network goes down, in such a case, whether we give priority to consistency or whether we give priority to availability. So this is the concept around cap theorem. Some of the databases give priority to consistency, and some of them really give priority to availability. So depending on the use cases and the criticality of the data engineers choose a right data model for storing their data. Now, coming to the programming aspect, right? So traditionally, when relational databases were there, data engineers were spending a lot of time on writing SQL queries, I mean, for data processing, right? But with the emergence of these distributed computing frameworks and streaming, data engineers are increasingly doing programming with the programming languages, right? So, what are some of the emerging programming languages and widely used? I mean, again, this is not an exclusive list, but I tried to put the major ones that people use. So Python is undoubtedly a fantastic language for dealing with data, and then there are number of libraries in Python for data science. Now, I mean, SQL is pretty understood, right? Every day, everybody uses. And Scala is another language, which is a functional programming language, which is predominantly used with Spark um, to build the data pipelines within Spark. And Java and .NET are, I mean, these are little traditional languages, but they are still being widely used in the data processing systems to build APIs around data. And Julia is, I mean, it's recently created in MIT and it is gaining good popularity. I didn't try it myself, but it is claimed as a dynamic programming language which can really solve problems around data and time series analysis. So data engineers now in the current scenario are expected to have at least one or two programming language skills, and they need to have expertise around how to choose the right model for their data, and they need to also think about the scalability and availability aspects of the data. So they play a crucial role in managing the data assets within the organizations, right? So that's how data engineering is evolving in the data intelligence world. I would like to share one thought that runs in my mind when we really think about data intelligence and its emergence, why things are changing a lot. So a lot of these things are emerging and changing because data is rediscovering its value, right? So we have seen I mean, we are able to now predict what's the world's computing capacity, for example, and how much of storage potential that the world has. So this is all data, right? Data is rediscovering its potential, and data is rediscovering the data itself. So with that, I would open for questions. Request the to open the audio line for audience. Can we write REST API connection for HiveDB? Okay, so we can definitely write REST API for HiveDB. Hive has a lot of connectors, and you have Microsoft has ODBC connector for Hive, and there is a new open source tool that is actually built these days called Livy, which can really query the data from Hive. Of course, it actually uses Spark in the middle as a processing engine, but that can Livy can give you an off-the-shelf REST API for your Hive. I hope that answers that question. Other than Livy, I mean, for Hive, it's nothing different than any other database, though. But we need to remember one thing: Hive is not really optimized for interactive queries. So the motive of really building a REST API here is to use it as a interactive query engine. Hive is not built for that. Hive is built for doing batch-oriented analytics. But if we have a use case to do some batch-oriented analytics over a REST API, yes, we can go ahead and then build it. Now, what are some other questions? Okay, so what are the difficulties to migrate data from this databases like MongoDB to Google Big Tables or other databases? Okay, so difficulties around migrating the data. I mean, So there are the basic problem around migrating data are two things. One is the physical distance, right? The physical barriers cannot be mitigated with the technologies, right? The other one is around the model differences. So when you model the data in MongoDB versus in Google Bigtable, because of the model difference, you need to transform your data, right? Now, how complex the transformation would be depends on how complex the structure is actually within the actual store that we have. So uh, I don't know about Google, but if we really take example of AWS, right? So AWS has some of the interesting facilities to at least move the data to cloud easily. So they have ways to, they can actually send a unit. I don't remember what is that called, but they can send a storage unit to the on-premise, and then we can store all of the data in that device, and then we can just put that device into some of the AWS closed data centers, and then your data is immediately available in the cloud. So the other way that you can easily move is AWS Direct Connect. So AWS has a Direct Connect feature in some of the US regions, where you can just plug in your data center to AWS data center, and then you can easily move. You can remove that physical barrier. But the logical transformational barriers are really subjective, and it depends on actually how complex the data is structured within the databases. Okay. Uh, okay. So this is interesting question. I use MySQL now. Can you please suggest whether to move Hive or not? Okay. So it's a good question. MySQL is a relational database, and Hive is also good for storing relational data. Although you don't have formal foreign keys and stuff, uh, the the key question is this in this scenario: how do you want to use the data after you put it in Hive? What is the use case that is centering around this data that you have, right? Again, Hive is not really meant for interactive queries. Hive is built for analytic workloads. So if you have a very interactive application on top of your MySQL, moving to how Hive will be not give you any benefit. Uh, Whereas if you are doing a lot of analytical aggregates on top of your MySQL database now, and you may have some benefit from by moving to Hive. However, it also depends on the how you can really partition your data to really take advantage of the map reduce processing. Or even, I mean, if you have Hive, you can probably use Spark. That is a good option to really do analytics on top of Hive. Yeah. So it depends on use case. If it is analytics use case, yes, go for it, but use it with Spark. That will be good. Can you provide us more info on what would be the best pattern to pace up the career learning path using data intelligence? Okay. So this is more around career, what people should learn, if I understand it correctly, to really build career in data intelligence, right? So I suggest to really look at least one data streaming platform and how it can be used, and look at the scalability and availability aspects of that one. And I strongly suggest to also learn these distributed databases. Not one, at least try to choose one distributed database per model, right? Say one document database and one relational database and one analytical processing engine and one indexing store, for example, I mentioned about solar and elastic sets there, right? So pick up one technology for each of these models, and then try to really experiment around it, and then really try to solve some of the problems around it. And also, I would suggest to really look at some of the information that is available on these distributed computing models in the cloud documentation, either AWS or Google has. And you can actually go for certifications for Google Data Engineer. That's a pretty good coverage of topics and what some of the engineering aspects around data. Data intelligence. Okay, can you touch on the subject you mentioned, data intelligence as an ecosystem? Okay, so I mentioned data intelligence should be adopted as an ecosystem in the organizations, because it is not just one thing, right? So it involves starting from organizational strategy to governance to really building the foundational capabilities to really acquiring the data assets. And it also is in other words, it is a multidisciplinary field. It is not just limited to data engineering. It also has data science in it. It also has data visualization aspects. It also has the compliance and legal aspects to really think about. So all of uh, these things cannot happen in one way, right? So if you really put all of these things into the organization, working collaboratively with each other, that becomes a ecosystem in the organization. That hey, who there will be people who will be building the data assets and then managing them. There will be experts really looking at the domain aspects of the data, and there will be data engineers who will be looking at engineering aspects, right? So an ecosystem should be able to effectively connect all of these people in a framework. So that's when it becomes effective, right? So uh, that's how I described it as an ecosystem. Okay, so the next question is, I think data migration tools for these DBs are not available or very few in the markets. Okay, so we can think about uh, tools for data migrations, for example, right? So there are so many ETL tools available. Uh, Tools like Informatica or SSIS, or these days Apache NiFi is also emerging as a tool for really managing data flows. So, but you do also have a modern ETL processes that can really help doing the data migrations, right? So, for example, Apache Spark is a good example. So Spark has connectors to a lot of different databases. So you can easily read the data from, say, for example, a SQL database and then move to Hive, or you can easily read the data from Hive to and move to say SQL, right? So it has a lot of connectors, and then more and more connectors will be built to work with Spark. So Spark will become a modern ETL engine. You can easily do these migrations, and Spark is an in-memory processing engine. It can really do the data migrations very fast. And if there are transformations also, actually it's a good processing engine to really explore for migrations. Okay, well, thanks everyone for attending the webinar, and also thanks a lot for the questions. With this, we will conclude the webinar today, and have a great day, everyone.